Right now, probably OIT. Where are you going to college?
OIT. You're going to OIT.
Oh, whoa. Well, I probably just want to talk to me. What? I'm screaming the mill right now.
Is there another one?
No, he's just having the people show them. He's showing us.
We'll do another one.
The stuff of
The way.
All right, so let's see. Jonathan, what'd you do here? So we want to first of all find the impulse delivered to the bullet, right? So the impulse, and we're just using the impulse momentum relationship, which is just what? Delta P equals what?
Force times the change of time.
F delta T, right? Okay, change in momentum. Anytime we do a change in, it's just final value minus initial value, right? So let's see here. What's the initial momentum of the bullet?
Zero.
Zero. It's not moving, right?
Zero.
Okay, so P naught is 0. P final is just going to be m times v, right? Whatever the velocity is. Okay, so we have to be careful about this though, because you guys were evidently, because the units are messed up. The units are not in standard units. So grams. How many grams in a kilogram? 1,000, right? Good. So then I have to move the decimal how many places?
To the left.
3 to the left. Good. So the mass is going to equal 0.0234, and then the velocity is 1086, right? And so our delta P is just equal to, this is a calculator problem, right? So whatever that product is minus 0. Right, everybody with me?
make sure to subtract.
Subtract that 0, yeah, that's going to complicate things, huh?
Oh, wait, what is that number over there, Sam? On the calculator?
What number is on your backpack?
6,000.
442.
So 0.0234 times 1086 is 25 point, so we would have an answer of 3 sig figs, 25.4 kilogram meters per second, right?
Yes.
Okay? Good. What was it again? 25.4. Okay? Now what about part 2? The average force acting on the bullet. So if this is equal to 25.4, we have an equation to solve, but what are we missing?
Time.
Okay, but we can do kinematics on this,
Yeah.
right? We know that, let's look at the kinematic quantities. So we know kinematic quantities, V naught is 0, V final is 1086, and we want to find delta T, right? We don't know the acceleration, but we could do some calculating here if we needed to. So how did you guys do this? You finished first, so you get to brag about this. How did you do this? How did you find T?
Oh, we put it into equation 4.
Equation 4, okay. So you could do equation 4 because you also know delta D, right? The displacement of the bullet is just the length of the barrel. In meters, what would that be? 0.677. So we know delta D in standard units would be 0.677. And so you could use equation 4. That would work great.
Why
Equation
did you
4.
find T?
Say it again.
Why did you find T? Couldn't you just find A?
We can still have to find T eventually.
Okay, so what you did, I got it. So what you did is you found A and multiplied by M. That's fine. You could do that. That would be fine. Right, that works. You could also do it this way. You could also find delta T. What's another way you could find delta T? Well, what's the average velocity is going to be what? Because it accelerates uniformly. So it starts at 0 and ends at 1086. What's the average? 534. Good. So the 534 would be the average velocity, right? And we know delta D is 0.677. So if we use that formula,
It's 543. It's not
delta.
543.
Oh, whoops. Yeah, you're right.
Okay, we all make mistakes.
So delta D equals V bar, average velocity, delta T, right? So then, delta T, if I divide each side by V bar, would just be displacement over average velocity, right? So we could just put in delta D, so 0.677 divided by average velocity, 543. And what'd you get? Oh, actually, hang on. That's delta T. I got to multiply by force, right?
Yeah.
Okay. You see how we can do this? Okay. So we get 0.677 divided by 543 is our time. We're going to multiply that. Actually, hang on. We go up to this equation up here, right? And we're going to solve for F. I was getting this all messed up. So if we're gonna solve for F, I would just divide each side through by delta T, right? And that's gonna give me, if I do that, I'm gonna get F equals delta P, which we have, over delta T. So what were those numbers? We had a number of 25.4. Well, there it is right there, right? Divided by delta T. That's that little number right there. And so we get M divided by M is 20,400 rounded to 3 places, right? That's a lot. But that makes sense. There's a really large force acting on that boat. Okay, make sense? Okay, good? All right. Moving on. Okay, next one. Okay, what's this one? Okay, so go to
I don't got it.
you don't got it yet? Not showing up? Okay, there you go, refresh.
Hey, there it is. Go speed racer.
Okay.
Is this
That was a good.
is
that's
it a
good European?
trick question? Is this off a movie I've seen? Is it a European or a African?
So type in that answer if you want it.
Alright,
Your question could be an answer.
There's no logic there. You have to see.
We got the right answer. Submit. You
Okay.
can submit. You have to submit it.
Okay, so now you guys, you have a minute. On this one, you only have a minute to make your guess.
Yeah, we were wrong.
It says African.
African. I was thinking you were referencing a movie. Oh,
We actually had a different.
obviously you
unit.
have not seen.
Huh?
We had different units. Because it says include units, meters per second or miles per hour.
But didn't I tell you what kind of units to use?
It says meters per second or miles per hour.
Mm-hmm.
And then it just, the answer is meters per second.
Oh, no, it'll also take miles per hour.
Oh, does it tell
Yeah.
you the answer in that?
No, it just says the answer in meters per second.
Seriously thought you were referencing a movie.
Me too.
Thanks, Abby.
Hold on,
It tells me we're gonna go with African.
Okay, 20 seconds.
What?
So there's no
Oh, we got 2 groups that got it.
Kate, have you seen that movie?
No, I
I got it
Like,
first.
if you've seen the movie.
You got it first.
Yeah, it
I
makes
was thinking.
perfect sense.
Wait.
Yeah, but.
Okay, so the correct answer was,
11 meters per second.
okay, so you guys actually got the numerical answer right. What was your answer?
11 meters per second.
Oh, you got it?
Yeah,
Okay.
we just did mouse.
You also could have said the question African or European or African, and it would have given you.
They said African.
Yeah, we said Africa.
Oh, but you had to be the question.
Yeah, you can't.
Oh,
say
you-
European or African.
I am
Okay, just so we're clear. Well, we went
It's
with
from a movie.
we went with African because an African can carry a coconut if it really needs.
Wait, what about miles
All
per
right,
hour?
so
What
this
is
is
this
word
movie?
for a minute. You get to choose. You want
Somebody-
to.
Wait, I'm not
Not
question.
many.
What's the name of this movie?
We already
How many
got-
points is
Money,
it?
five
Search for the
hundred,
Holy
two.
Grail.
Okay, so you want to roll for odd or even for all of yourself, or do you want to split them up?
It is so funny.
Should they roll? They already have points on the board.
Wait, what if we put
Okay,
miles
you
per
can be my
hour?
witness.
Hey, you gotta always get the good with this.
Okay, odd or even.
Wait,
Odd or even,
wait.
we only have
How-
two,
how-
we-
how
there's
many-
only 2 points on the line, right? Like
Yeah.
Yeah.
Well,
Odd or
just
even,
roll it.
roll the die.
Well, I just got odd or even.
Spot, Scott. It's
Okay.
we split it.
Today, preferred.
Odd or even, right now.
Abby, odd. It's odd.
Hell yeah.
Wait, what if we
You
put miles per
you
hour?
put 'em up there.
24.
This is Jim.
24?
I'm not gonna
Yeah.
guess.
Yeah.
You guys don't know that. You're never gonna know that.
Scott wants us to do it.
Hey, what was the question? What did you have to write for the question?
Why am I doing it? I'm gonna have the most
Could it be
difficult
carried
time
by an
doing
hour?
it.
Does it matter?
Your question would have been right. What would you have to write?
Probably because I'm short-handed.
24 miles per hour or 11 meters per second.
Yeah.
Or European or African.
Question mark?
Yeah.
No, just if you just put both those words in there, it would have given it to you. Okay, so here you go.
Just mark them, Scott.
What you know what number you are?
Four.
We're
Let's take
four.
four.
Yeah, we're
So we're number 4?
Do you know? Okay, I'll tell you. You are.
We're 5.
Are you
At
5?
the beginning of the movie.
Yep,
I
5.
told you you were 5.
So it's okay if I go right here?
Yep. Oh, don't use that one. Yeah, that would not be good. There you go.
Wait, click it on pen.
Clicking on pin.
Good.
Yeah, change the color.
Change the color, change the color.
Jesus Christ.
Let's be
Go back to
honest.
yellow. What color do we want?
Light blue.
What
White.
is
Light.
No, I want brown.
Okay, hurry though.
I want brown.
We're going to go for
Don't
Nice,
choose a
nice,
stupid
nice.
color, Scott.
this one.
Blue?
Blue.
Okay.
Somebody already chose that. Orange.
Okay,
No.
orange it is.
I want to throw up now.
Do that brown color,
We're
Scott.
5, right?
Can we kick Scott off our team?
No.
Alright, you get 2 points. Put it up there. Hurry.
Make it count.
Of
There
all
you
of our
go.
team members, you want to kick off me.
Okay, here we go. Here we go.
This is so stupid.
It is so funny.
Minutes.
Wait.
Okay, here we go. Have a look. So I need phones away. Phones away. Phones away.
We don't have
Um,
connection either.
Yeah, we don't
Wow.
have connection.
No
That's
one
okay.
cares.
That's okay. I want to talk about this one. There's a couple things we need to kind of look at here. So
Alright, because we were all.
So if we take a look, I'm gonna draw this picture, right? So we've got this rifle. So there's my rifle, right? I'm gonna make the bullet.
Honestly, I'm not.
There's the
It's
bullet,
like a little coach gun.
okay? Yeah. It's not much of a rifle, but that's not the point.
Hey, if you gave it a little longer stop, or so I can get in the stop.
It'd be
There you go.
passable,
Yeah.
passable, all right. So, what we have to do here is we have to first ask ourselves, okay, what is the closed system? The closed system includes, what does that mean? We've talked a little bit about this before, but if we talk about a closed system in physics, what does that mean?
They go open like.
In the
It
bullet.
doesn't have like other variables.
Okay, so there's no other external
No external.
forces acting, right, on the system. So everything would be internal. Like we looked at an example earlier in the year, we talked about if you're in a car and you push on the floor of the car, even though somebody's driving erratically, it's our natural instinct, but it doesn't do much because those are forces inside the car, right? In order for the car to slow down, the car has to be able to apply a force to the ground, and the ground applies the return force to the car, right? Okay, so what about this then? So our system includes both the rifle and the bullet. They're floating in space and they're motionless. So what's the momentum of the system? 0. Okay. So that means that if all the forces are internal that are acting in the system, then the momentum must stay zero of the system, right? So now that's before, this is after. I'll try to correct a little bit better, but not much. So there's the rifle, and here's the bullet speeding away. It's still, the system still includes the bullet and the rifle, correct? If the momentum is zero, though, what does that imply? The bullet is speeding away to the right, so it's obviously got some positive momentum, doesn't it? What's that tell you about the rifle then?
It needs to move the opposite direction. Is
Encased with oxygen.
Okay, it's encased with oxygen. It's got to have a negative momentum so that the two add up to zero, right? Okay, now think of it this way, right? Momentum is just mv. The bullet has a very small mass, but it has a very large velocity, right? So we'll call that mass of the bullet, velocity of the bullet. Let's look at the rifle. Large mass and therefore small velocity, right? It's moving back in this direction. The bullet is moving in that direction, and so we'd have mass of the rifle. Oops, sorry, took it backwards. It's going to be a large mass and a small velocity, right?
So if you got a big enough rifle, the rifle wouldn't move much?
Well, it's not much, but it's going to move a little bit. No matter what, it's going to move a little bit. Right?
But as the mass approaches infinity.
Okay. Right. But if the mass were really large, I mean, try something. Everybody close your eyes real quick and just focus real hard. Close those things down for a second. Close those down. See if you can pick this up here. So close your eyes and see if you can sense this. Okay, ready? When I say go, I'm gonna start walking towards the door pretty fast. Okay, ready? Go. Did you feel it?
Yes.
Did you feel the earth rotate back a little bit?
Yep.
A little bit.
Just a little bit?
Just a wee bit.
Because it had to.
No whiskers.
It had to because the system is closed. The system of me and the planet is closed. And so if we're starting off with zero net momentum, let's say, I mean, sure, the Earth's spinning, but from our perspective, let's say that they're both motionless. If I push off in this direction, so I get some positive momentum forward, then the Earth has to roll back a little bit. Because momentum has to be conserved. It's a little more complicated because it's actually twisting, rotating instead of just moving in a straight line. But you get the idea. It's the same concept.
So if we got everybody on the world to walk.
Oh my gosh,
in one
I was
direction
just
for
thinking
long
that.
enough, we could get the world to stop spinning.
No, our mass is too insignificant.
Yeah.
I was telling
Our mass is pretty small.
How many rockets do we need?
We'd need a lot. We'd need a lot. So anyway, that's how you do this problem, right? So we're just gonna know, if we know what the momentum of the bullet is in this direction, the rifle would have to have an opposite momentum in the other direction, right? And if we divide the momentum by the mass of the rifle, we should get its velocity. Okay? What was the answer?
6.67.
That was like 4.96.
4.9, so it's gonna be a relatively small number, but that's why you get recoil too, though, right? I mean, it's fast, if it was something like 5 meters per second, that's pretty fast.
So if
I mean, that's like 10 miles an hour, so that rifle's gonna come at you at 10 miles an hour. If you don't have it against your, firmly against your shoulder, that could be a bad thing, right? I mean, that thing's gonna be painful.
So like, if you just
Really
straight, if you're like just shooting and you wanted to reduce the recoil for whatever reason.
Yeah.
If you just got like a whole bunch of lead weights and just attached them onto the gun.
Yeah.
That just, that's why.
Mhm.
That's
Probably
why.
like a 50 cal at least.
That's why.
So the, interesting little story, so